Hey guys, this is for the first little video I'm making for after Christmas break. It's on what we're going to be studying, which is ionic bonds. Eventually we'll be talking about covalent bonds, but I want to talk about ionic bonds, and for the most part that's a bond between a cation, which are these metals over here, okay, and an anion, which is these nonmetals over here. And I want to talk about how those work, and I'm mostly going to be using electron dot models, so to kind of exemplify how they work. So if you don't understand electron dot models, you need to go back a couple of modules and understand why I'm putting little dots by different elements. So the first thing I want to show you is how lithium might bond with something from group 17. Lithium's in group 1. Okay. Things that are in group 1, reminder, they're going to lose one electron in a bond to become a +1 ion. Let's say a lithium were to make a ionic bond with something from group 17. Let's say a fluorine ion. 1, 2, 3, 4, 5, 6. Okay, so right now this is called lithium, and this is called fluorine. Okay, an electron, that electron from the outer shell, the outermost shell of lithium, will come over here and fill that outermost shell of fluorine. Okay, so that they now both have outer shells, and it goes from being called lithium and fluorine to lithium fluoride. Okay, that IDE right there, that means that an ionic bond has happened. This is IDE, that IDE symbol we use. And what that means is two elements bonded to form a binary compound. Binary means just two things together. Okay? IDE, that's a suffix that stands for binary compound. And let me show you how another one's going to work. All right. Again, I'm just going to use electron dot models to show you. And let's play with one from group 2. It's a metal. Okay, let's take calcium. Okay, and I'm going to put the two dots over here so they're nice and convenient. Okay, and let's take something from group 16. Oxygen. Okay, so calcium is going to lose its 2 electrons in its outermost shell to oxygen. Now remember, when this takes place, oxygen will be -2 charged. You know, it's an anion. It's going to have those 2 electrons. And calcium, it loses 2 electrons. Remember, electrons are negatively charged. So calcium is going to be +2. Okay, it's a cation, which is what we call. Now remember, what we're going to call this. This is calcium and oxygen, but when they form a bond to become calcium oxide, that IDE, it's going to change its name. It's going to change its name to calcium oxide because it's a binary compound. Now, it doesn't always work smooth like those two. Okay, I'll give you an example where it doesn't work smooth, and then we'll make some more videos so that you get really good at showing these ratios and how these things come together. Okay, let's take, for example, sodium and sulfur. Okay, sodium's a group 1er, so just like lithium earlier, it's going to have that 1 dot. Sulfur is a group 16. kind of like oxygen. Okay, so just like oxygen, it's going to have those 6 dots, right? So, same thing's going to happen. This metal is going to lose an electron to this nonmetal, all right? The problem is that doesn't satisfy the rule of octet. In order to satisfy the rule of octet and make 8 electrons, you're going to need that second sodium. Now, you can have sodium oxide, sulfide. It's poorly written, but you get the gist. Okay, so the way we would write that, we have to use something called a subscript. Sub, like a submarine means down below. So we would write that like this, Na2, that means 2 sodiums, and S. Okay, I'm going to stop right there with that video and give you another video to help you. That's an introduction. Okay.